Good morning, everyone. My name is Paulo Miguel Bercero from 3AB Psychology A, and today we're going to discuss a continuation of the test revisions, specifically the quality assurance during the test revision and the use of IRT in building and revising tests. One thing that psychologists do to obtain data is by administering psychological tests for them to obtain quality assured data. So mechanisms are put into place by test publishers in the course of standardizing a new test or re-standardizing existing tests. Now let's have a look into how quality control mechanisms for examiners, protocol scoring, and data entry are done. So, for the purpose of a singular idea illustration, let's draw an example from the procedures followed by the developers of the Wechsler Intelligence Scale for Children, fourth edition, or the WISC 4. Now, in developing new tests or re-standardizing or renorming existing tests, test developers seek to employ examiners who have experience testing members of the population target for the tests. These are examiners with extensive experience in testing children and adolescents since this is a WISC 4. Now, potential examiners need to complete rather a questionnaire by supplying information about their education, professional experience, certification, and licensing status. Now, although it might be desirable for every examiner to hold a doctorate degree, this is simply not feasible given that many thousands of tests might be or might have to be individually administered. Rather, the professional time of a doctorate level examiners tends to be at a premium, not to mention their fees. Now, moving on to the training process. Now, first is usually the training process takes form in a written guidelines for the test administration and involves everything from classroom instruction to practice test administration on site to even videotaped demonstrations. Now, publishers can quiz potential examiners to determine how well they know or learned what they need to know. Third, during standardization of the WISC 4, examiners were required to submit a review case prior to testing additional children. Then, lastly, during the course of the test, all selected examiners received a periodic newsletter advising potential test administration problems. Now, inside the newsletters provides ongoing ways to ensure quality assurance in test administration. Moving on to the protocol scoring. So, in protocol scoring, examiners may be involved to a certain degree in the final scoring of protocols. Regardless if it's the examiner or a dedicated scorer, people who are responsible for scoring protocols typically undergo training. The quality assurance in the restandardization of the test is maintained by having two qualified scorers rescore each protocol call collected during the tryouts and standardization stage of test development. If there were discrepancies or inconsistencies in scoring, these are resolved by another scorer referred to as the resolver. So the resolver are selected based on their demonstration of exceptional scoring accuracy and previous scoring experience. Another mechanism to ensure consistency in scoring is the anchor protocol. An anchor protocol is a test protocol scored by a highly authoritative scorer. This is a model designed to resolve discrepancies. So, a discrepancy between scoring in an anchor protocol and another protocol is called a scoring drift. So, in the occurrence of a scoring drifts, scorers are immediately notified to prevent repetition of the error and to correct the scoring drift. Lastly is the data entry. So once protocol are scored, the data then must be entered into a database. To ensure quality, during data entry phase of the test development, developers may employ computer programs to seek out and identify irregularities in the scoring reporting. And lastly, in addition, a proportion of protocol data can be randomly selected to make certain that the data entered match the data originally contained. Now, moving on to the use of IRT in building and revising tests. So, we noted that in item response theory, or IRT, could be applied in the evaluation of utility of tests and test programs. So, let us elaborate on the possible roles of IRT in test constructs as well as its pros and cons with classical test theory, or CTT. Now, one disadvantage of applying CTT in test development is the extent to which item statistics are dependent upon characteristics of the group of people being tested. So, basically, all CTT based statistics are sample dependent. Now, from a CTT perspective, let's say, give an example. A certain construct, might be judged to be very high in difficulty when it is administered to a sample of people known to be very low in that certain construct. From that same perspective, though, the same construct might be judged to be very low in difficulty when administered to a group of people known to be very high in that said construct. Now, using IRT, test developers evaluate individual items' performance with reference to the item characteristic curves, or ICC. So, ICCs provide information about the relationship between the performance of individual items and the presumed underlying ability or trait level in the test takers. So, there are three of many possible applications of IRT in building and revising tests. This includes evaluating the properties of existing tests and guiding test revisions. Second, determining measurements equivalent across test takers, population, and lastly, developing item banks. But for this report, we'll specifically focus on the evaluation of the properties of existing tests and guiding tests revisions. Now, in evaluating the properties of existing tests and guiding test revisions, IRT information curves can help test developers evaluate how well and individual items or the entire test is working to measure different levels of the underlying construct. So, an example of an item information curved is presented, where each item represents an individual curved line. Now, developers can use this information curve to weed out uninformative questions or to eliminate redundant items that provide duplicate levels of information. So, information curves allow test developers to tailor an instrument to provide high information or precision. So, information curves or graphs suggest that by adding more items to the test or by adding more response options to the existing items, it will help the test developers obtain more precise data of the needed test construct. So, by adding appropriate items or response option will both broaden the range and increase the height of the curve across the underlying construct, resulting to an increase of precision in measuring your test. So that would be all for my report. The continuation of the other two discussions under the use of IRT in building and revising tests will be discussed by the next reporter. Thank you very much.